Can densification make land safe from earthquake liquefaction? Imagine a city built on loose, waterlogged soil suddenly shaken by a powerful earthquake. The ground might behave like a liquid, causing buildings to sink or tilt. This is what happens during liquefaction. But can making the ground denser help prevent this? Let's find out. Densification is a process that compacts the soil, reducing the empty spaces between soil particles. When soil is tightly packed, it becomes stronger and less likely to lose its shape during an earthquake. This means the soil can resist the forces that cause liquefaction. Liquefaction happens when saturated, loose, granular soils shake so much that they behave like a liquid. The water in the soil pushes particles apart, weakening the ground. Densification limits this by making the soil more resistant to movement. There are different ways to densify soil. Vibratory compaction uses machines that shake the ground to pack the soil tighter. Heavy tamping involves dropping heavy weights onto the soil to squeeze out air and water. Driven piles, which are long columns pushed into the ground, also help by compacting the soil around them. Sometimes, piles made of wood or concrete are driven close together to reinforce the soil. The closer the piles are, the better they work to prevent liquefaction. Historical earthquake data shows that densified sites tend to suffer less damage. For example, during the 1960 Niigata earthquake in Japan, areas that had been densified experienced fewer problems. Similarly, in the 1990 Northridge earthquake in California, densified zones held up better than loose soils. But densification alone isn't enough. It is often combined with other methods like drainage to remove excess water or solidification to bind soil particles together. Drainage reduces pore water pressure during shaking, making the soil more stable. Stone columns, which are filled with gravel or crushed stone, can also be installed to stiffen and drain the ground. Practical use of densification includes strengthening the ground beneath foundations, embankments, and other structures. Engineers often combine densification with reinforced foundations, piles, and beams to improve overall earthquake resistance. However, densification is not a magic fix. Its success depends on soil type, depth of treatment, and how strong the earthquake is. It is most effective in loose, sandy soils close to the surface. For deeper or clay-rich soils, other methods may be needed. In the end, densification can significantly lower the risk of liquefaction, but it does not guarantee complete safety. It works best as part of a larger plan that includes careful site selection, soil testing, and strong structural design. So, to answer the question, yes, making the ground denser can help make land safer from earthquake liquefaction. But it should always be used alongside other techniques to fully protect buildings and communities from the unpredictable power of earthquakes.